Good morning, students. Today we are doing the applications of dimensions. The first application of dimension is to check the correctness of the equation. That means we have to check whether the equation is dimensionally correct or not. If the equation is dimensionally correct, then the dimensions of all terms in the equation will be same. I will just give you an example, then only you will understand clearly. I am just writing an equation v is equal to u plus at. Is this familiar to you? Right, and you already know this equation is correct. Okay, now how will we check whether the equation is dimensionally correct or not? How many terms this equation has? First term, second term, third term. You have to take each terms separately and find the dimension of each terms. We have to take each terms separately and find the dimensions of each terms. So what is the dimension of v? V is velocity. So you can write Lt minus 1. What is the dimension of u? The u is initial velocity. Again it is Lt minus 1. Now At, A for acceleration, T for time. So how will I find the dimension of At? Dimension of acceleration is Lt minus 2. And then time. Dimension of time is T. So multiply both. Lt minus 1. So just see, I am just taking each terms. Dimension of first term, Lt minus 1. Dimension of second term, Lt minus 1. Dimension of third term, Lt minus 1. So you can say equation is dimensionally correct. Got it? We will do one more exercise. S is equal to ut plus half at square. Ut plus half at square. So how many terms are there? First term, second term, third term. There are 3 terms. So as I told, you have to write each term individually. We have to write each term individually. Now let us write the dimensions of each terms. What is the dimension of S? S is displacement. So dimension of S is L. Next one, dimension of ut. U is Lt minus 1 and T. So the answer is L. Now see the third one, half at square. Half is a constant, half will not have dimension. So we have to write the dimension of at square. So A, the dimension is Lt minus 2. Then T square. Dimension is T square itself. Multiply. Therefore you will get L. Now look, first term the dimension is L, second term dimension is L, third term dimension is L. So the dimension of all the terms are same. Therefore we can say equation is dimensionally correct. Now let us do another exercise. P is equal to F into V I'll write FV plus work into time. I'm just giving an equation like this. P is equal to FV plus W into T, where P is power, W is work, F is force, V is velocity. So these are the quantities given. So we have to check whether this is dimensionally correct or not. So let us do. How many terms? There are 3 terms. So I am writing all these 3 terms separately. Now we are going to find the dimension. So what is the dimension of power? You have already studied it, the dimension of power. ml square t minus 3. So I write ml square t minus 3. Now F into velocity, dimension of force into velocity. So force is mlt minus 2, velocity lt minus 1. Now multiply both. So m l square t minus 3. Now we will go for third one, work into time. The dimension of work is what? Yes, m l square t minus 2. That's the dimension of work. And time t. Then you multiply both. What will you get? m l square t minus 1. Now just compare. First dimension, this ml square t minus 3. Second one, ml square t minus 3. Third one, ml square t minus 1. So that is wrong. So if any one is wrong, then the equation is not dimensionally correct. So this equation is not dimensionally correct. Okay. Now, if one equation is dimensionally correct, it can be correct if I add some constants. For example, I am just giving an equation v square minus u square is equal to as. You already know the correct equation is v square minus u square equal to 2as. But if I check the dimension of this equation, you will get this equation is dimensionally correct. So, but a constant value that is 2 is missing here. So, if one equation is dimensionally correct, when we just multiply with a constant or divide with a constant, we will get the correct equation. But if one equation is dimensionally wrong, you can't make that equation correct again. Okay? So this is all about the first application. We will do with the next application in the next section. Thank you.